well. But before we do that, I just want to take these 10 numbers that are here. Secret undercover Department of Health and Mental Hygiene study randomly selected restaurants on St. Patrick's Day. Again, this must have been a spring semester example as opposed to the autumn one that I put together on the homework. Finds that the number of slices of corned beef and the lunch specials on St. Patrick's Day were as follows. I'm going to copy all of those numbers, and I'm going to open up Excel. Okay, I'm going to paste those numbers into Excel. Boom, that worked out okay. And I'm going to blow it up so we can see it a little easier. I'm going to line these up into a vertical column. Okay, there we go. 16 restaurants. These are the number of slices of corned beef that were in the sandwich in the 16 restaurants. And I'm going to say to myself, okay, let me do some calculations here. Let's see. I'm going to say, what's the average number of slices? Okay, mean it's going to be equal to average, parentheses, and I'll find the average of all these. Okay, roughly about 10 slices. So what's the standard deviation? It's going to be equal to the standard deviation. By the way, you'll see me when I type in equals STDEV, and you'll find this in many of the calculations that I do. Among the suggested results that come up are standard deviation here, but there's also other kinds of standard deviation that Excel does as well. Most of the time, those are newer versions of the same function. They're functionally going to be the same, except in certain special situations. You'll see me tend to ignore that and just use the old function, okay, which is just standard deviation, because for our purposes, it's really not going to be any different. So I'm going to, that's my standard deviation. Now, what's my sample size again? Sample size is 16. I'm going to do it this way, just so we can see that you can do it. Count, parentheses. I'm just going to highlight all of these values, and it'll count it for me. Sample size is 16. So in this case, if I calculate 95% confidence interval, what am I going to use, the Z distribution or the T distribution? T, it's more small sample size. So our standard error is going to be equal to, is going to be equal to the standard deviation divided by the square root of the sample size. Yes. Okay, and that's our standard error. So what is our confidence interval going to be? Well, let's calculate our margin of error. Our margin of error is going to be equal to, what's going to be equal to? Well, I need the T value now, don't I? So let me see if I can't do that here. Equals T inverse. Let me see if this will work for me. I think it will. Okay, the probability is going to be 0.05, comma, degrees of freedom is going to be 15, right? See if I get it right. Okay, remember what we got before? 2.13, same thing from the table. So I can get that from Excel as well. Just to show you again, equals T inverse, right, parentheses. Okay, it wants the probability. Now this probability is a probability outside of that range, 0.05. 0.05 for 95% confidence interval is 0.05, for 99 is 0.01, comma, degrees of freedom, which is 15. Okay, again, I get that same value. So what's my margin of error going to be? It's going to be equal. It's going to be equal to 2.13 times my standard error. Okay, there's my margin of error. So now to calculate my confidence interval, it's going to be equal to my mean minus my margin of error, and it's going to be equal to my mean plus my margin of error. Okay, so there's my 95% confidence interval. Small sample size, I did the same thing with Excel. I'm going to repeat this one more time. Anybody got an idea what I might do with it now? Another way I can solve this? I'm sure that this is a distant memory now, but it's going to come back to haunt you again. Slices. I'm going to drop it on my desktop. Nobody has an idea what I'm going to do next. How about if I start up SPSS? Let's solve the same problem using SPSS. We did it manually. We did it with Excel. Now we're going to do it with SPSS. How are you guys doing online? Okay. You guys got SPSS on those computers? Okay. Do you want me to slow down while you copy those numbers in? If you're interested in it, do it with me. I'll read them to you. If you want, I'm going to import these values into SPSS from Excel. But if you don't have them available in SPSS, what you can do is you can just go into the first column and you can type them in. I'm gonna import them right now. Open. Yes. When I did Excel?
Yeah.
You mean from Excel? Sure. Okay. I kind of ditched it, but that's okay. That's all right.
It's okay.
No, I can do it very quickly again. Now, if you have a question about it, chances are other people do too. Oops, I got to open it. Recent slices. Okay, there are my slices. Okay, so first thing I did was calculate the average, right? I need the mean in order to calculate confidence interval. I need the standard deviation to calculate it. I need my sample size, which was 16. I know that already. I need my standard error. Well, my standard error is going to be equal to the standard deviation divided by the square root of the sample size, which is 16. Okay, so that's going to be 3 point. Did I do that right? Yeah, it's okay. Okay, so that's my standard error, right? So what is my 95% confidence interval going to be? It's going to be equal to x bar, the mean, plus or minus, right? My t-value, either 1.96. I'm going to put 1.96 in here as a placeholder, but it's really going to be the t-value that's based on the sample size, which turns out to be 2.13 times my standard error, which I just calculated up there. Well, t turns out to be 2.13, right? So my lower value is going to be equal to my mean, 10.025 minus 2.13 times my standard error. Okay, I think that should work, right? It's going to do the multiplication first and then subtraction. And I think that's the answer we got before. And the other way, it's going to be equal to my mean plus 2.13 times my standard error. Okay, so that's my 95% confidence interval. Okay, so now I'm going to take these. I'm going to import these. Now I can say I want to open a data file in SPSS, and I can tell it, let's go to my desktop. Okay, I got to kind of navigate there. And I'm looking here for the slices Excel file that I just created. You might have seen me save it as slices.xl. Okay, so now where did it go? I don't see it there. The reason why I don't see it there is because SPSS right now is fixed to only open file types of SAV, its own file types. So if I click on that and change to Excel files, you will now see that file. And there's the file I'm interested in. I just created it before I saved it after I copied those numbers in. So I'm going to say, let's open that. SPSS brings up a window which tells me, first of all, do you want SPSS to read a variable name from the first row of data? Well, you guys may remember there was no variable name at the top. It didn't say slices, just had a data number. If I don't uncheck that, it'll think that top number is the name of that variable. So I got to uncheck that. Okay, and it says it sees data from A1 to A16. So that tells me it's really keyed in on the data I want. I'll click OK, and it'll open up a new data file for me with those numbers. So I'm going to read them quickly if you want to type them in. 10. Now you could actually, if you just wanted to do it this way, you could literally just type in these values: 10, 7, 14.0, 13, 9, 7, 12, 15, 10, 12, 12, 8, 9, 6, 4, and 13. Apparently nobody put half a slice into the sandwiches. Right? The discrete values because nobody used half a slice. All right. So, since I didn't give it a variable name, SPSS automatically assigned it when it calls it V1. If I wanted to go into the variable view, I could recode that column, that variable. And I can say, oh, that's slices. That variable name is slices. Whoops. Okay, remember the rules. You got to start with a letter. You can only have letters and numbers. Okay, can't have any spaces or special characters. And I'm going to give it a label. Okay, I'm going to say slices of, what did I say, pastrami or corned beef, right? Slices of corned beef. And all the rest of this, it's not a nominal variable. It's guessing it's a nominal variable because it sees only integers. It really isn't a nominal variable. It's a scalar or numerical variable. Okay, so I need to change that so SPSS handles it correctly. Okay, so I've changed that. I'm going to go back to the data view, and you'll see that it changed to slices, right? The variable name. Okay, so now I'm going to do my calculation. I'm going to go up to Analyze. I'm going to go to Descriptive Statistics, and I'm going to go past frequencies. Frequencies is usually used for nominal variables. You're going to do counts, right? You're going to count the number of left-handers and number of right-handers. I'm going to count the number of people in this age range, this age range, this age range. I'm going to count the number of redheads, brunettes, blondes, so on and so forth. So I'm going to go instead to either descriptives or explore. I'm going to start with descriptives. I'll click on descriptives. You could use either one of them. And now it asks me what variable do you want to move into the workbox. Okay, well, I made up two other variables inadvertently because I was typing in numbers to show you how to do it. So I'm not going to ignore that. I'm only going to move in the variable slices. Okay, now I have a number of options. If I open this up, it says, oh, it's going to calculate the mean, the standard deviation. I'm going to add in the variance, the range, just for the hell of it. I'll click continue. Notice I don't see confidence interval in there. I'm going to click continue, and I'm going to click OK. And it's going to go ahead and do the calculation for me. When it does the calculation, it opens a completely new window called an output window where all of the output information is stored. So what did it find? Well, the sample size is 16. We knew that. The mean was 10.062, the same thing we calculated by hand and by using Excel. And the standard deviation was 3.12. I don't see the confidence interval here, right? So we need to go a little bit further. I'm going to go back up to Analyze again. Anytime we want an operation done, we're going to go to Analyze. Analyze descriptive statistics. I'm going to go past frequencies, descriptives. I'm going to go to Explore. Explore is going to give us descriptive statistics again, except it's going to give us more different kinds of statistics, descriptive statistics, and it's going to give us the opportunity to do some other things as well. So I'm going to move slices into the dependence list, right? And then I'm going to go into statistics, and it says, oh, well, look, descriptives, confidence interval for the mean 95%. Not only do I have the opportunity now to have it calculate the 95% confidence interval for me, but if I want to change that, I could calculate the 99% or the 90%, or if I really wanted to be freaky, the 87.5% confidence interval, right? Literally anything we wanted to put in there. It can do some other things like calculate percentiles for you and so on and so forth. For right now, that's what we're really after, the confidence interval. It's automatically going to calculate many other statistics, but for now, it's going to do it automatically for us. So I'll click continue. I'm not interested in any plots right now, but if we wanted to we could ask it to make some additional plots. It's automatically going to do a box plot for us, no matter what we say. So right down here, it says, what do we want it to display? Just the statistics, just the plots, or both? I'm going to leave it on both and say, okay. Again, it does a calculation. It creates an output table, and here we are. Okay, so what do we have here? Well, the sample size is 16. The mean is, as we said before, 10.063. It's got the median, the variance, a whole bunch of other stuff. Well, notice now it calculated the standard error for us as well. So having the sample size, the mean, the standard error, now it can calculate for us the confidence interval as well. Okay, so did it use the t-score or did it use the z-score? It used t. How do we know that? We know that because it came up with the same answer that we did when we used 2.13 instead of 1.96. Okay, if I have a sample size of 300, is SPSS going to use the t-score or the z-score? It's going to use a t-score. If I have a sample size of 5,000, what's it going to use? T. It may use it, no matter what the sample size is, it's going to calculate a t-score, and it's going to use a t-score, even if the t-score is 1.9600000001. It's always going to use a t-score, right? Because it has that facility. It's not. It doesn't have the constraints on time or accuracy that we have. Right? So it's always going to use a t-table because that's the more accurate one, and also because it's reflecting reality. We never know what the population is. No matter how big the sample is, we never really know the population mean or standard deviation for sure. Okay, so just to go back, I'm going to do one more thing with confidence interval, and then we'll move on to some problems that involve this idea of hypothesis testing. Okay, and the last thing I want to do here is I want to do something with proportions. Okay, so but we're going to work, it works exactly the same way, except that, don't we have some rules about proportions? Wasn't there some kind of rule about proportion that we had, that they had to have a certain sample size, right? Not only that, but wasn't there also a rule that you couldn't have a situation where you had like 100, where you're talking about if you had a proportion where you had 100 people and say the prevalence of something was 20%, you had 20 people and you had 80 people in the two groups, so it was 20 people and 80 people, so it was 20% of the people had the disease, let's say, the prevalence was 20%, 20 out of the whole 100. But if you had a situation where you had